consider sigmatropic type of reactions. According to the definition of sigmatropic reactions, the shifting of sigma bonded atom or group which is flanked by one or more pi electron system to a new position which is represented in bracket I, j within the molecule in an uncatalyzed intramolecular process. So where this I and j are nothing but the I, this I and j are the initial and final position of migrating atom or groups. So the I and J represent the initial and final position of migrating atom or groups. While studying sigmatropic reaction, the few things should be remembered. The first one is the reaction is uncatalyzed intermolecular rearrangement, and the second one is it involves the migration of group of atoms. Now in this case we are going to consider the migration of atoms only, and that should be hydrogen. So due to this, the position of atom is also fixed, that is one which is represented here, and the position of J is unknown, that is very depending upon the starting material. So let us understand by this considering example. So the first example is one painting. So the numbering should be represented this. This is different from the regular impact nomenclature system. So when the sigmatropic reaction is with this one painting, in this case the hydrogen atom which is at one position will migrate at the position 3 and the bond will migrate at the position 1, 2. Due to this migration, it forms a cyclic intermediate. It forms a cyclic intermediate like that. This hydrogen is here, this body is there, and in this the numbering that is 1, 2, 3. Okay, the double bond which is at 2, 3 position is also shifted to the position 1, 2, right? So this is transition state. Now this is a 4-member transition state which has very high strain. So that transition state immediately collapse into the product like, and the product which is shown like that. So again numbering should be here. This is 1, 2, 3. Numbering should be according to the starting material because we have to find out the position of hydrogen in the product case. Now if you look at the position of this hydrogen in the reactant case, it is at one position, while in the product case it is at third position. So here it is, you can also mention that you can see that this bond is broken, right, and this bond is formed, this new bond is formed. So we can see here this is new bond, new sigma bond is formed, and this bond is broken, So while sigmatropic reaction, one bond is broken and new sigma bond is formed. That is the identification mark. Now in this case the position of hydrogen is shifted from 1 to 3 position. So the reaction is considered as 1,3 sigmatropic rearrangement. So this is 1,3 sigmatropic rearrangement. 1,3 sigmatropic rearrangement. Or one can say it is 1,3 sigmatropic shift. It is 1,3 sigmatropic shift. So this is the first example. Now consider second example. In the second example, this is 1,3 pentadiene. This is 1,3 pentadiene. Again in this structure the numbering shown it is different from the regular IPAC nomenclature system. Regular IPAC nomenclature numbering should be start from this, exactly reverse of this. 1, 2 is here, 3 is here, 3 is here, this is 4 and this is 5. So don't misunderstand by the numbering which is shown in blue pen, or the numbering which is shown in the black pen. So the blue numbering is for the sigmatropic rearrangement, and while the black numbering is for the IPAC nomenclature system. So again, we can see here now the hydrogen which is at this position, the hydrogen which is at one position will migrate at this fifth position, then bond will migrate like that. Due to this migration, again this molecule forms a transition state, which is 6-member transition state. Here it is also a 6-member transition state is formed. So due to the migration of bond, the internal system will be dotted. So the again numbering should be like that: 1, 2, 3, 4, 5. Okay, this is 6-member transition state. It is quite stable, but it is a transition state. It is also collapse into the product, and it forms the product. Okay, the numbering should be, this is 1, 2, 3, 4, 5, and now this is hydrogen. Now you can see here that in the reactant case, that hydrogen is shifted from one position to the 5 position. Here we can write down here, and the bond between 4 and 5 is shifted to 3 and 4. Here it is the bond, and here it is the bond. So you can see here this bond is broken and this bond is formed. Okay, the new sigma bond is formed. Sigma bond is formed while it is sigma bond is broken. So again one sigma bond is broken and another sigma bond is formed. That is the characteristics of sigmatropic rearrangement. Now let us consider the last example. Now in this case, in this case the hydrogen which is at one position is migrated at the 5 position. So this type of reaction are considered as 1,5 sigmatropic rearrangement. This is 1,5 sigmatropic rearrangement. Or it is 1,5 sigmatropic hydrogen shift. 1,5 sigmatropic hydrogen shift is there. Okay. Now the last example is, so in this case it is 1,3,5 heptatryne. So it is 1,5 heptatryne. So same in this case, the hydrogen which is at one position migrate at the 7th position, and the bond which is migrated like that. Due to the migration of bond, and and transition state is formed. Okay, this is hydrogen and this is the, so this bond is, so I'm going to write down the position of bond also. This is the migration of bond. Okay, so this is a transition state. So this transition state collapse into the product, which gives, this is hydrogen, the bond is here, the numbering should be start here: 1, 2, 3, 4, 5, 6, and this is 7. Okay, if you look at the position of hydrogen, in the case of starting material it is at one position, while in the product case it is at 7th position. And the bond here, it is the bond of hydrogen between one carbon atom is broken. This bond is broken. Okay, sigma bond is broken. Now here it is, here it is new sigma bond is formed. New sigma bond is formed. So now this is 1,7 sigmatropic rearrangement. Add the hydrogen from one position is migrated to the 7th position. So this is 1,7 sigmatropic reaction, sigmatropic rearrangement, or it is 1,7 sigmatropic hydrogen shift. So student can practice this exam. I hope student will understand the basic idea behind the sigmatropic rearrangement, how the bond is cleaved, how the new bond is formed, and how we can represent this migration of bond in the transition state.